All right, this video is on aromatics, specifically one particular compound that we're going to learn about, and that is benzene. So benzene, if we see that benzene is the longest continuous carbon chain, and if it's the parent chain, we call it exactly that. We call it benzene. But if it is a side group, we call it phenyl. So before we learn the naming rules associated with benzene, let's actually look at what it is. Benzene has a chemical formula C6H6, okay? So it's a very specific compound. So it has 6 carbons in a cycle, right? So it's a cyclohexene because it has a few double bonds. So it has a double bond here, here, and here. So every other carbon has a double bond. And there are 6 hydrogens as well. So there's a hydrogen at each carbon. Okay, so there's this structure for benzene. There's actually an equal structure that benzene can also be found as. So it looks very similar, and notice if you can spot the difference. So it again has 6 carbons all together. There are double bonds, and there's a hydrogen at each carbon as well. So either one of these structures would be correct when we're talking about benzene. And the difference between these two is the location of the double bonds. So you've got the double bonds here, here, and here. And then on this side, you've got the double bonds here, here, and here. So what ends up happening with benzene is that the double bonds actually switch spots. So every once in a while, these double bonds are kind of moved over. And that's the same for this side as well. So between these two, you can't actually say that the structure of benzene is the one on the left or the one on the right. In reality, it's somewhere in between these two. And this is what we call a resonance structure. We're not going to get into too much of resonance because a lot of this is stuff that you'll learn in university, and we honestly don't have the time, nor is it in the curriculum for us to go through this, right? We're just learning about benzene specifically. So benzene has what we call a resonance structure. As far as you're concerned, you only need to know that these double bonds are not at a one set location, but they're shared among all of the carbons. So because of this, when we actually draw our structure for benzene, it's neither the one on the left or right, it's the one that I'm drawing right now. So here's a 6 carbon cycloalkene, but instead of drawing the double bonds at specific locations, we're just going to draw a circle in the middle. That implies that there is a double bond shared equally between each of these carbons. And this resonance, this structure, gives benzene some very unique properties, which we'll take a look at later. So the structure of benzene looks like that. As I mentioned earlier, if our longest continuous carbon chain is benzene, we would just have the benzene as its name. There's no need for prefixes. There's no need for the endings to change. It's just benzene. So let's take a look at this example and let's try and name this. So I see that I've got a benzene and I've got one side group. So the longest chain is benzene. So I'm just going to name that as benzene. And then in order to name my chlorine, because it's a side group, it's going to be chloro. And notice, just like the previous lesson, when we're naming something like this, there's only one possibility for where the chlorine is attached to, and that would be carbon number 1. So because there's only one side group and one of this chlorine, wherever it's attached is going to be carbon number 1. So this is just going to be chlorobenzene. And I'm happy with that. That is the name for this particular structure. There's a few different variations that we're going to need to know. So we're going to first try and name all 3 of these. If you want to go ahead and give it a shot, pause the video and see if you can name these. So the first one here, I have to give the numbering here to 1, 2, 3, 4, 5, 6, right? So again, 6 carbons, but it's at positions 1 and 2. I can even start numbering here and go this way, counterclockwise, 1, 2, 3, 4, 5, 6. Anyway, whichever way you number it, the lowest possible combination you'll get is that the chlorines are at carbon number 1 and carbon number 2. Because of that, I'm going to name this. So my parent name is benzene. And I have 2 chlorines, so I'm going to call it dichloro. And the locations are at 1 and 2. So 1, 2 dichlorobenzene. When we take a look at the second one, our side groups, we don't actually have any letters there. So that means this carbon and this carbon, those are the side groups. So I've got a methyl group here and a methyl group here. This, when I number this, the lowest possible numbers I could get are 1 and 3. So this is going to be 1,3 dimethylbenzene. And here, when I number it, my 2 lowest numbers are going to be 1 and 4. So when I do that, my name here is going to be 1,4-diiodo benzene. Now the thing here is that these placements 1, 2, 1, 3, and 1, 4 on benzene are unique. They're so unique that we call it a very specific name. There's a few categories, or there's a few criteria for us to call it these names though. So first of all, if you have this location 1 and 2, and if they're both the same side group, so in this case they're both chlorine, I can call this ortho dichlorobenzene. So that is this particular compound. And I know that those positions, so ortho is always positions 1 and 2. So if I have the same side group at 1, 2, instead of writing 1, 2 dash, I can call it ortho. This is more important if you are looking at a compound and it's asking you to draw it and then it says ortho. You should again know that it's positions 1 and 2. If it's 1 and 3, it has a different name. It would be meta. So meta dimethylbenzene would be this one. Again, meta position is 1 and 3, and it always has to be the same side group, right? At those 2 positions. And same thing here, it has to be the same positions at 1 and 4. If that's the case, we would call it para. Para-diiodobenzene. Okay, so I've got 3 different possibilities here. 1, 2 position, 1, 3 position, and 1, 4 position. When I'm talking about position, I'm talking about the number of the carbon in that particular benzene, right? So is it on carbon number 1? Is it on carbon number 2? Carbon 3, 4, 5, 6? If it's 1 and 2, we call it ortho. If it's 1 and 3, we call it meta. If it's 1 and 4, we call it para. Now let's take a look at a situation where the benzene is not our longest continuous carbon chain. So if you take a look here, I've got 1, 2, 3, 4, 5 carbons in that chain. Now you might be thinking to yourself, that's a little bit weird because that's not more than the benzene. You're right. The reason why that is still the parent chain has to do with this double bond. When you have this double bond here, you would have to number it so that the double bond gets the lowest possible number. So in this case, 1, 2, 3, 4, 5. So if you've got a chain that has a double bond in it, that becomes the parent chain. Same with a triple bond. If there was a triple bond in there, that would be the priority. And then you have to name this as the parent chain and add this on as the phenyl group onto that chain. So the longest chain here is pentene. So again, there's a few ways that you can show this, right? So there's 1-pentene, or you can write this as pent1-ene. Both of these are fine. Okay, so after I have that section in, now I just have to include this. So when we have a benzene as a side group, we call this a phenyl. And this phenyl is at position number 4. So it would be 4-phenyl, YL, 1-pentene, or 4-phenyl, pent1-ene. Okay, so that is how you would name phenyl or benzene as a side group, which is what we call phenyl. There's a few compounds that have benzene as a part of it that there's no rule associated with it, but you should know this entire compound. So this all together, when you've got a benzene with an OH attached to it, and we'll learn about OHs when we learn about alcohols, this is phenol. And this, when you've got a benzene with an NH2 attached to it, that would be aniline. Okay, so these are just two that you need to know. There's no rule associated with naming these, it's just ones to know. So this entire compound is aniline, and this is phenol. In terms of practice, I want you to try and do these. So try and draw these molecules to see if you understand this. All right, that's it for that lesson.